Okay, so I found a new version of the hierarchy of biology that combines both of those pictures that we've been looking at before. I'm so excited about this. This is what teachers do in their free time. I'm like cruising Pinterest, and I'm like, oh my God, the perfect hierarchy of biology triangle. Make posters, tell everyone. So I'm really excited about this. Sorry. So check it out. So this upside down triangle, this hierarchy of biology, I love it because it combines both of those pictures, right? It's got the living components, right? Everything that's living, remember the smallest living thing is the cell, and then the non-living components. Remember, these are organized in order in terms of size. So we're talking about, when we're looking at this diagram, we're looking at size, and we're also looking at complexity. So the smallest thing that we're going to be talking about this unit are atoms. See, they're almost at the bottom of this upside down triangle. So we'll be talking about atoms. We will be talking about, I'll use yellow for you. We'll be talking about atoms here. We'll be talking about molecules. Remember, when we put atoms together, we get molecules. And then macromolecules. We've heard this word before, but it was a long time ago. Don't worry, I'm gonna refresh. But here is where we are on the hierarchy of biology. We are going way small, all right? Where we're gonna start today is talking about properties of water, all right? So I've told you, we're in the atom zone, in the molecule zone. So let's put that in the context of water. So this is a throwback up top here, that picture. We have talked about molecules before, all right? We talked about them in our characteristics of living things unit, and I used water as the example, okay? So water is an example of a molecule because it is composed of one or more atoms, all right? Our atoms here, we've got an oxygen. You can see it's marked. We've got one oxygen. It's marked on this nice picture right here. And then we've got two hydrogens, all right? We've got two hydrogens. So we've got that red oxygen, two hydrogens, H2O. You guys know this, right? H2O. So why are we spending so much time on it? Why is it important? So water is a really special molecule. It's got really unique chemical and physical properties that allow for metabolic activities or metabolism in our cells. So if we did not have water in our bodies, our cells would not be able to do chemical reactions. Because remember, metabolism, this is from cellular energy. You might remember that unit, it was a while ago, about 4 ago. So metabolism is all of the interactions between molecules in a cell. So for example, we learned about photosynthesis, we learned about cellular respiration, how all of those reactants, those ingredients, get rearranged to form different products. That's a chemical reaction. We get one thing going in, rearrange those molecules, and something else coming out. So that is metabolism. A lot of times when we think about metabolism, right, we think about like a diet or like trying to increase our metabolism, or someone says they have a fast metabolism. Here, when we're talking about metabolism, yes, we're talking about, that chemical reaction in your body, of your body taking food and turning it into energy. But that's just a small portion of what metabolism means. We're talking about all of the chemical reactions that are happening inside the cell. And like I said, we've learned about 2 chemical reactions, photosynthesis and cellular respiration. Those fall under metabolism. They're a chemical reaction that happens in the cell. Okay, you knew where I was going next, right? So metabolism is one of our big 5 life processes. You see this slide like almost every unit, right? It came up in the bingo yesterday. Our 5 life processes. Every living thing has to do these, all right? To stay alive, to keep their species going. Remember, so growth and repair, that's growing and healing. Metabolism, ding, 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 that's what we're talking about. That's chemical reactions. Example of one that we normally think about, right? Taking food, doing chemical reactions to get energy out of it. All right. Reproduction, we've talked about that, cell division or babies, making more cells. Gas exchange, one gas in, breathing in oxygen, another gas out, carbon dioxide. And then finally, response to stimuli or being able to react to your environment. You've got to be able to do all of these to stay alive and to keep the species going. So you can make tons of yummy things dissolving stuff in water, right? We use this property all the time. Well, one of the properties that makes water really important for life is that it is a solvent. A solvent. All right? So a solvent is something that dissolves chemicals. Like we were talking about dissolving Kool-Aid in water. Water can dissolve a lot of different chemicals, minerals, and nutrients that we need for those big five, those life processes. If we didn't have water in our bodies and it wasn't able to dissolve those chemicals, we couldn't do those life processes. And, we'd die, or our species would, go extinct. So solvent is a really important property, that water is a solvent. So when we're talking about this vocabulary word, solvent, I've got this picture right here. So solvent is what, the chemical or the mineral is being dissolved in, all right? So, our solvent here is the water, okay? And then solute, there's another vocabulary word. The way that I like to remember this is what you put in. Solute, it's what you put into the water. So here I'm putting Kool-Aid into the water, and you can see, I'll even color in red. Here's my little Kool-Aid molecules, right? It's not coming out perfect, but we're trying. So most of my molecules in this solution, all right, are the water, right? When you pour in the packet of Kool-Aid, it turns red, but most of the molecules in there are actually water. That is the solvent. And the solute is what you put in, the Kool-Aid, and together they form a solution. Solution. Fun vocabulary word. So water is an awesome solvent. That's one of its important chemical and physical properties. Another really unique physical property to water is that it is polar. Polar. So when I hear that word polar, I think about like a polar bear, right? Polar bears, they live in the Arctic, so in the North Pole, or maybe you think when you hear polar, you think the North Pole, the South Pole. That's good. It's good to think that. Because water has a North Pole and a South Pole. It has two different ends that are opposite charges. So you'll see up here on my molecule, this is a water molecule, H2O, right? There's two hydrogens, one oxygen. I've got a negative end. This is like the North Pole, or, it could be the South Pole, depending on the orientation of the molecule, right? And then here, we've got a positive end of the molecule. So there is a negative end, or a negative pole, and a positive pole to this molecule. Okay, so who cares? It's got a north and a south pole. Why is that important? Well, this means that part of the molecule is a little bit negative, and another part of the molecule is a little bit positive. And remember, we learned in our last unit, or you knew this before, opposites attract, right? Opposite charges are going to attract. So if part of this molecule has a different charge, it's going to attract to other molecules, for example, water molecules. They're able to stick together because their positive and negative ends are going to attract to each other. So why is that important? Why is that special? Well, it causes these properties called surface tension and cohesion. So here I've got surface tension. This is a water bug, or a water strider. I apologize. If you've ever been to the outdoor lab, you might have seen these water striders. If you are interested in going to the outdoor lab because you've never been there or you've been there before, I do want to give you guys a little commercial. There is an open house that is happening on Saturday, May 15th. So you and your family can pile up in the car and you guys can actually go there and do different activities. Obviously, they'll be, observing all COVID-19 protocols, and you do have to sign up in advance. But go to their website and definitely check that out. You can see some water striders. You can see some surface tension in action. These bugs are able to kind of walk on the surface of the water. If you've never seen this, you might have heard of the basilisk lizard that can like run on top of the water, right? How does it do that? It's because of surface tension. That surface is able to support that bug or that lizard as it runs, all right? Those molecules are able to push back, and that really is helpful to this bug. Okay, other property is cohesion. And I know this picture is a little bit small, so I apologize. It's hard to find a picture of cohesion. So water molecules, they, as I said, are attracted to each other. So you can see here, we've got two water molecules grabbing onto each other. So water is a sticky molecule. It will stick to itself. That's called cohesion. Like when you collaborate with the people in your group, right? You guys do that all the time. Next class, we're gonna have some group work where you guys are gonna collaborate. You work together. But guess what? The water molecules also collaborate. They do cohesion and they work together. Another interesting property is called adhesion. So not only are water molecules sticky to each other, they are sticky to stuff. They're sticky to other things. And this is really useful, for example, in plants, right? Maybe you've thought about, well, how does a tree get water all the way from the roots to the top of the tree? Well, it's got straws, it's got these tubes, and the water is able to stick to the sides of those tubes to climb up the tree, as well as to each other. They're able to climb on top of each other or stick to each other to get to the top of the tree. All right, last one. Final kind of chemical and physical property that we're going to review for water that makes it, really unique and really important for life. And this is that water is a thermal regulator. It's a thermal regulator. Another way to say this is that it has a high heat capacity, and you'll see this in our activity tomorrow. So what do I mean? It's a thermal regulator. Well, here we've got a throwback. You've seen this cycle before. We studied in ecology the water cycle. All right. And remember, water is able to move all around, cycle through an ecosystem. Here we've got it, we've got this, say, lake. We've got evaporation, condensation, precipitation, transpiration, percolation, so many Asians. But basically that water is moving around in the system, all right? And so why is that helpful? Well, water itself is actually really good at holding heat, all right? It's a really good molecule for keeping in heat. And so why is that useful? Well, it helps stabilize the temperature of the area, all right? So, all of us have experienced before when, like, it was warm outside, and I feel like this happened, I don't think it happened this year, but it happened a couple years ago, where, like, it was literally, like, 50 degrees, and the weatherman was like, tomorrow there will be a foot of snow on the ground. And I was like, that's definitely not going to happen. It's 50 degrees outside. How could there possibly, that's like a 30 degree, a 20 degree difference that has to happen to get from 50 degrees to like, 32. There's no way that's happening. And I woke up the next morning, there was no school, and there's a foot of snow on the ground. What? Air can change temperature quickly, like that, right? One day it was warm, I was wearing a t-shirt, the next day there was snow. Water can't do this. So water, it takes a long time for that water to cool down, or it takes a long time for that water to heat up. This is why when you're boiling water to make ramen, I know we didn't have as many fans in this class, but like sometimes it feels like it takes forever. Water is able to absorb a lot of heat and hold it in before increasing or decreasing its temperature. And so what that means is this is great for all the living things in the ecosystem. The water is going to be, slowly increasing temperature or slowly decreasing temperature. This is why we don't have any furry fish. Like if you've ever been fishing or looked at pictures of fish, there's no furry fish, right? They don't need fur to stay warm. The water, it doesn't change temperature like really, really fast. It's slow. And this helps keep the environment stable. It also applies to, because we've got that water circling through the ecosystem. This is one reason why at the beach, a lot of times it's warmer at the beach, at the coast, than it is here or farther inland, because that water is holding in heat and it's able to release some of that heat to the air and keep that temperature more stable. All right. So this is really helpful for living things, kind of helps keep things stable.